consider an angle on a standard coordinate plane, and then we're told some things about this angle. Right, let's point out the things. I'm told that the secant of that angle is -6/2, and the tangent of that angle is positive. And then we're told, figure out from these clues what is the cosecant of theta. Now, we've run into this type of problem before. We've done a couple examples of it, but I still want to go through all the basics in this video and just make sure we're all on the same page with starting out in a standard coordinate plane. You always solve these problems by drawing triangles. So where is this triangle going to live? That's my first question. Is it going to live in quadrant 1, 2, 3, 4? Where are we? Well, tangent of theta is positive in two places. Tangent is positive in quadrant 1. It's also positive in quadrant 3. Okay, so that's useful. Now, where is the secant negative? Okay, think about that. Secant of theta, if that's going to be negative, then that also means, since, remember, secant is the reciprocal identity of cosine. Secant and cosine are reciprocals. If secant is negative, that means cosine is negative. Okay, so what this problem is telling me is that tangent is positive and secant is negative. So let's figure out where secants are negative. Well, secants are x values. Cosines are x values. So here's where cosine is negative, and also over here, cosine is negative. Remember, if cosine is negative, that means secant is negative. So there we go. We are operating in quadrant 3 for this problem. And you need to figure that out before you can get anywhere. Now, there are versions of this problem that work in quadrant 1, 2, 3, or 4. And they start out with all sorts of information, right? So you really just have to look closely and determine what quadrant you're working in. Could be any quadrant, and they could be giving you secants, tangents, sines, cosines, whatever. So I'm not in quadrant 2. What am I doing? I know I'm in quadrant 3. So let's draw a triangle in quadrant 3. It does not need to be an accurate triangle. It just needs to be in the right quadrant. So here's my right triangle, and here's my angle theta, which I don't know what that is, and I probably won't figure that out. But look at what we're told. Now let's get more specific. I'm done with tangent information. I'm told that secant of theta equals -6/2. Okay, that's nice. I actually like cosine better than secant. So I'm going to turn this into some cosine information. Cosine of theta equals 2/-6. And if you like, you can reduce this. It won't make any difference. But we can reduce that to -1/3. Now let's label the triangle. Remember what cosine is. Cosine of theta equals adjacent over hypotenuse. So great. What's the adjacent side to that gigantic angle right there? Okay, that angle doesn't live in a triangle, so it might be very confusing to think about what's the adjacent side. I want you to remember that when you have triangles outside the first quadrant, you need to use a reference triangle with this angle, the reference angle. And if you remember where reference angles are, that's the angle between the terminal side of theta and the x-axis, the shortest distance. So there's my reference angle. I'm going to use the cosine of that reference angle instead of the cosine of the angle theta. So the cosine of theta equals 2/-6. Well, adjacent is 2, and hypotenuse, there we go, -6. What's wrong with this picture? You can't have a negative hypotenuse. And aside from that, my 2, that length 2, that should be negative because it's going to the left. So switch these. And that's okay to do because if you think about cosine, okay, check cosine of this thing, that's going to be -2/6, which is exactly the same as 2/-6. Okay, so always double check your plus and minus signs and make sure that hypotenuse is positive and your negative is going in the right direction here. Okay, so great. Now we've got a triangle that has two sides. I just need one more side. I want to know what the y distance is right there. So using Pythagorean's theorem, -2 squared plus y squared equals 6 squared. So that means 4 plus y squared equals 36. That means y squared equals 32. That means y equals the square root of 32. Okay, there we go. So we put that in here. Let me just make, whoa, hold up there. Okay, so y equals the square root of 32. Let's go ahead and mark that on our graph. And try not to make another mistake. Here's the mistake that people make. They say, oh, square root of 32? Just write that on the graph. But take a look at your graph again. This is quadrant 3, where the y values are negative. So that has to be a negative square root of 32. Okay. Now, the reason I can get away with that is because when you do a square root, what you really ought to be doing is a plus or minus square root, and then pick the sign that makes sense in your picture. Obviously, positive square root of 32 is not going to work, so we choose negative square root of 32. And now I have a complete picture. This triangle can now be used to solve whatever it is we're looking for. I can't even remember anymore. I want to know what is the cosecant of theta. Okay, and remember, cosecant is 1 over sine of theta. So what's the sine of theta? Well, sine of theta, according to our triangle below, I'm going to use reference angle, the sine of theta is the y value, negative root 32 over the hypotenuse, 6. So when you figure out the cosecant, you just flip that over, right? We're going to say this is, let me get some space here. This is going to be 6 divided by negative square root of 32. And if you want to simplify that fraction, bring the negative sign up, cross some terms out, fine. You can just write it 6 over negative root 32, or you can simplify it. It does not matter. As long as you go through the process, which, let me outline these steps just as a closer. Draw your triangle, and I mean your reference triangle, in the correct quadrant. Step 2, solve the triangle. And step 3, use that triangle to find the trig function that was asked for.